11.6, 11.7, day 2, volume of pyramids and cones. Alrighty, volume of the solid, measure of the space inside three-dimensional figure, number of cubic units in the interior. We've already done volume before, but now we're using it for pyramids and cones. A lot of the same stuff, just knowing what variables you have, punching them into the formula, and then going from there. Now, I mentioned this in a help video. If you haven't seen the help video for 11.5 and you're watching this for the first time, we mentioned that B is the base. Not only the base, but big B means the area of the base. Your base could be a triangle. It could be a equilateral triangle. It could be a trapezoid or polygon, regular polygon. We found that how to find the area of those two-dimensional shapes, but then your job is to find that area using these formulas, right? To then punch it into the formula and then go from there. The first thing you need to do is identify what base you have. It could be a circle. It could be a triangle. All those different shapes that I just mentioned. And we have formulas that will help us find those different shapes. And for example, if you have a pyramid like this, or everything this is a pyramid when everything converges on that one point. Here is your base, right? And so I'd be using a rectangle formula for this, or a square formula for the big B, the big base. That's where a lot of people have trouble. This is 1/3 times the base times the height. I would, at the end of the day, just divide everything by 3 once you get your answer. That is going to be your best way to punch it in the calculator. But yeah, that's for general formula for the volume. Pyramid or cone. Let's look at a cone real quick. Volume of a cone, well, we said it was 1/3 times the base. Well, the base of a cone, like an ice cream cone, is a circle. It's always a circle for a cone specifically. So the base of a cone is going to be pi r squared. Right? You've seen that before. Times the height, and then you're going to divide everything by 3. Sorry for that extra line there. That's what we're going to be using. Now, this is the same thing as multiplying by 1/3, dividing by 3. It's the same exact thing, right? All right, let's find the volume of this cone. So we need, like we just said, we need pi r, radius. It looks like it's 8. If you do 8 squared, you'll get 64. Just to kind of simplify us down a little bit. The height is not 17. The height is going from the top to the middle of the circle there. Or it could have been labeled over here, right? Like this. But 17 is the slant going from the top to one of the sides of the pyramid or cone or whatever. So you do have to make a right angle here. And if you're slick, you can see that's a triple. If you don't see triples as easy, you could do 8 squared plus b squared equals 17 squared, Pythagorean theorem. But if you see the triple, you know right away this is a 15, 8, 15, 17 triangle. So you can then use 15 as your height. And then divide everything by 3. Then you're going to have your answer. I got 1,005.31 feet. And then it's cubed because we have volume, right? Fantastic. Let's go look at some other ones. Find the volume of the pyramid below. All right, first things first, identify what the base is. The base is a square. Everything's 9 at the bottom. So I can use the formula for a square would be s squared, right? Side squared is the base. Right, the big B there. So we know that it's everything divided by 3. And for the pyramid, remember it's base times height divided by 3 or times 1/3, whatever you want to do. I like just to divide by 3. So the base looks like it's 9 squared. So that'll be 81. Times the height. Oh, it's not the slant height anymore. This one looks like they give us the actual height going up and down. 10. Very good. Let's see what we get. Type in the calculator. Oh, we get a nice even 270 meters cubed. Find the volume of the pyramid. Oh, we have a triangle. Not only that, base is an equilateral triangle. That means all the sides are 5. Nice. We actually have a formula for that. You could use a couple different methods, but if you know the equilateral triangle, and I provided it for you there, right here, s squared times radical 3 divided by 4. So s squared would be 5 squared, which is 25, times radical 3 divided by 4. Right, that's the base times the height. Height looks like it's 19. Sweet. Divided by 3 or times 1/3, because this is, remember, base. Oh, I'll do a different color. This is base times height divided by 3 to find the volume of the pyramid. That's why I did times 19 divided by 3, pulling it from this over here, right? And that's what you're punching in the formula to find the volume. Take it as slow as you want. If you want to punch this stuff in first, the base, please do that. Then multiply by 19, then divide by 3. I got 168. Oh, not 168, sorry. Just 68. Um, 0.56, 56 hundredths centimeters cubed. All right. Notice it's a lot of identifying first what your base is, then punching it into the formula correctly, or identifying what formula you need to use. What formula you need to use for your base, and then following the rest of this volume formula. Use the formula to find another dimension. Whoa, we've done this before. It tells us the volume is 681 cubic inches. Great. The height is 8, and we're working with a cone. So that means we're using the base, right? B times h divided by 2 is going to be the pi r squared, because it's a cone, to find the area of the base there, times height divided by 2. So I'm going to put pi r squared divided by, why did I say divided by 2? Divided by 3. Yikes. I thought something was a little fishy there. Try that again. It'll be pi r squared times 8, which is the height, divided by 3. And that's going to get us our volume, which is 681. Now what I've told a couple people, we reverse engineer this guy, kind of, right, to find that r, the radius. This is what you do a lot in physics. I've kind of mentioned that before, but that's what we are doing. Let's see. I'd multiply both sides by 3 first. You should get like 2043 equals pi r squared times 8. Now you divide both sides by 8 and even pi, right? 8 pi. Because pi is constant. So these cancel, and you're just left with r squared. Once you're done with that, square root both sides. Sweet. I got something low, right? It shouldn't be something big. It really should be kind of tiny. 9 and 2/100 inches, because it is a radius, not a volume. So you don't get a cube or square or anything. It's just a distance. All right. Moving on. Find the volume of the figure below. Ooh, look at those two shapes. We got to find the volume of the entire thing. Now we have two different three-dimensional figures. So it looks like we need to find the volume of the pyramid, then find the volume of the cube, and then add them together. We've done something like that before, where we add the surface areas together, right? Of some different figures as well. So let's just figure out the pyramid first. Pyramid should be the base, right, is 7 times 7 times 7, which is 49. Oh, I want to write the base is 49. 49 times the height, which is 7. Right here. A lot of 7s in this one. Oh, there we go. Times the height divided by 3. Right? Base times height divided by 3 gets us our volume for the pyramid. We're going to add the cube now. The cube should be just s cubed, right? That's how we find the area of the volume of the cube. Now, if you wanted to stay technical, you would do the base 7 times 7 times the height, which is, well, 7. Really, it's just s cubed. So 7 cubed. Oh no, hold on. Here we go. 7 cubed. What are you doing? Silly. I need to press this. Oh, different colors. All right, great. So now we just punch all this in the calculator. The 7 cubed should be 380. Where is it? 343. Something that ask. 343 divided by 3. Great. I got final answer 4d7. Oh wow, that's a 7.33 inches cubed. Yeah, they're both inclusive of the volume, so we add them together. Unlike this next one, find the volume of the figure below. The shape of the cylinder, okay, with the cone hollowed out inside. So this is kind of like a nail situation where maybe you've nailed something into the wall and now you're finding this like area of the hollowed out stuff. So this is hollowed. And then now you're finding the area of all this blue stuff, right? Anything outside the nail or the screw mark or whatever you want. I don't know what you want to call it. The cone. Okay, so let's do it. So instead of adding these things together, what we're going to need to do is take the cylinder, because the cylinder is all inclusive of the entire shape. And then so it's got more volume than the cone. And so then we're going to take away the volume of the cone to find the remaining area. So we're going to subtract the two together. Well, the area of a cylinder should be the base times the height, right? So the base should be pi r squared times the height, okay? So that should be pi times the radius is 8. So 64, because 8 squared is 64. Times the height, well, it says the height of the cylinder is 9. All right, great. So that's one value that you're going to have. Subtract the cone, right? So you have pi r squared. Well, we know r is 64. Pi r squared times height. Sorry, I'm going to write the whole thing. Divided by 3. So we have pi times 64. So that's the radius of the circle up here. Times the height. Oh, we already knew the height. That's fine. And divided by 3. So the only difference between two is that this stuff is divided by 3 for the cone. Now, don't be like, oh, isn't it just, I don't know. You can't really subtract this stuff on top with this stuff. You have to do the divided by 3 because it's going to get you a different value. Alrighty. Okie dokie. Put in your calculator. I get 1,206.37 or 37 hundredths centimeters cubed. If you get a negative number, that definitely means you got something wrong because you can't have a negative volume, just like you can't have a negative area. Hopefully things are getting easier. If you need me to make a help video, oh my gosh, I need help on this. And I know it's a common trend. People are not quite getting a certain idea. I can make a help video, even if it's from 11.1 or 2 or whatever that is. I want to go back and make sure everyone's on the same page, understanding how to do certain things, and we'll be good to go. Hopefully, we'll finish strong here. All right, see you next time.